In this lesson, we will learn about the two types of concavity and points of inflection. This graph is concave upward. The tangent lines lie below the graph. The slopes of the tangent lines are increasing, which means f prime of x is greater than or equals to 0. This graph is concave downward. The tangent lines lie above the graph. The slopes of the tangent lines are decreasing, which means that f prime of x is less than or equals to 0. An easy way to differentiate between the two concavities is by inserting eyes on the top of a graph. If it resembles a smiley face, then it is concave upward because the smiley face is associated with positivity. If it resembles a sad face, then it is concave downward because the sad face is associated with negativity. This graph shows a point of inflection at this point. A point of inflection occurs when the graph has a tangent line at that point and the graph changes concavity at that point. You can see here that at the left of this point, the graph is concave downward, and at the right, it is concave upward. Therefore, the graph changes concavity at this point. Let's work on a problem. Using this graph, answer the following questions. 1. On what intervals is the graph concave upward? The intervals 0 and 1 is concave upward. If you were to draw a tangent line on any part of this interval, it would lie below the graph. The interval between 2 and 4 is concave upward as well. If you were to draw two eyes on the top of the interval, it would look like a smiley face. Intervals 6 and 7 is also concave upward because the slope of the tangent lines are increasing. Number 2. On what intervals is the graph concave downward? Interval -1 and 0 is concave downwards. If you were to draw a tangent line on any part of this interval, it would lie above the graph. The interval between 4 and 6 is concave downward. The slope of the tangent lines are decreasing. 3. In which intervals does the graph have no concavity? -2 to -1 has no concavity because the slope remains at 0 throughout the whole interval. The slope of intervals 1 and 2 also remains constant and does not change, which means there is no concavity. 4. What are the points of inflection? At 0, 1, there is a point of inflection. At this point, the graph changes concavity. It went from concave downward to concave upward. There is a point of inflection at 4, 1 as well. The graph goes from concave upward to concave downward. Before we start question number 5, you must know that in order to find concavity intervals and points of inflection, you must use a second derivative number line. 5. Determine the points of inflection and discuss the graph of fx equals x to the 4th power minus 4x cubed plus 2. First note that the domain is all real numbers. We must use the second derivative to find the concavity and points of inflection. In order to find the second derivative, we must first find the derivative of fx, which is 4x cubed minus 12x squared. Using the derivative of fx, we can find the second derivative. The second derivative of fx is 12x squared minus 24x. After finding the second derivative, find the critical numbers. F prime of x is never undefined. When f prime of x is 0, x equals to 0 and 2. Using these critical numbers, we can create a second derivative line test to find concavity intervals and points of inflection. Using the same concept of a first derivative line test, we can determine that from -infinity to 0, f prime of x is positive. From 0 to 2, it is negative. And from 2 to positive infinity, it is positive. Therefore, f of x is concave upward on the intervals -infinity to 0 and 2 to positive infinity. And f of x is concave downward on the interval 0 to 2. There are different signs on either side of 0 and 2. This means that there is a point of inflection on fx when x equals to 0 and 2. Using this information, we can locate the point of inflection by plugging 0 and 2 into the original equation. The points of inflection are at 0, 2, and 2, negative 14.